Hello and welcome to 379 Workshop 1 for Algorithm Analysis. My name is Tony Hill, and I'm a senior at the University of Michigan. And this is my project. So the overview will be discussing the problem at hand and telling you the constraints to solving the workshop algorithm. Um, I'll talk a little bit about space and time complexity and asymptotic bounds, and how they associate. And then I'll show you my algorithmic pseudocode. So discussing our problem. Who's friendly? So we are given a group of people, and we have to find out who is friendly with each other and who is not friendly at all. So when two people meet, they interact, and if one person's friendly and the other person's friendly, then we know that they're friendly. But if two people meet and one person isn't, then we know that they're not. We must sort this list of people, um, in order from non-friendly to friendly, so 0 to n-1. Our constraints for the problem: we don't have access to certain functions, such as get friends, where we can see who's friendliness, see who has friends, and we can't use get friendliness to see if they're friendly or not, and we cannot check to see if one person is friendly towards another person. And we're given a black box function, and in this function um, there is a Boolean operation. And the Boolean operation it's called meetup. It's gonna take two arguments. It's gonna take one person and it's gonna take another person, and it's going to see if they're friendly. Um, if they're friendly, then the function will execute, but the Boolean operation will be set to true. And also, we have to have at least two friendly people in order for this black box function to work. And um, so asymptotic bounds, they deal with the time complexity. So just like in math, you have, n squared and square root of n log n. And it's the same thing in coding, where you want to see how long it takes for your algorithm to execute. And we have easy times and we've got extremely long times. So, a more complex algorithm is going to have a longer execute time. And you can see if for for um, for some functions, n squared uh, by itself if n is 100, it's n squared equals a lot. It's higher than all the rest, and the square root of n, it's only 10. My algorithm uses it's a max of theta of n. So all my allocations, two arrays, and they're each 4 bytes. And then some integers, which are constant time. There's no time really associated with that. but my first nested for loop, it's got the integers with the arrays, and I do n times n, then I go to the if statement. So it's a nested for loop, so you basically have n times n, or n squared. And then the second for loop, I've got integers, an array with n possible, and it's got a time theta of n. So when talking about time complexity, there's also lower bounds and upper bounds. So your lower bound would be your big O of n, which is like best case scenario where it wouldn't have to execute all the way through. And then your omega of n, which is like worst case, and that's the max amount of time that it would take to execute. And I'll talk more about that when I show you my pseudocode. And then we have my sorting loop. The sorting loop also has integers with an n possible, with an array of n possible, and it's also got a time of theta of n. So the total time complexity for this will be theta of n squared, and I'll tell you that more in a minute. So if we're given, say, a sample group, we have Tom, Penny, Jess, and Bob, and we want to see who's friendly. Okay, we're going to use this algorithm. So I've got my declarations, my array, my function here is the f sort function, and it's got an array of persons, passing people with an int of n. And the first allocation is the friendly people array, which is 4 bytes, and then non-friendly people, which is another 4 bytes, n times 4 bytes. And then integers. So we've got the first friendly person and then the second friendly person. Now, these are going to be, as the code executes, it's going to find the first friendly person that it finds is going to find a second friendly person. There has to be two, given our constraints for the problem. And then we have another 2 integers with a count, our friendly count, and then our non-friendly count. And then I also have a Boolean that is basically don't stop. So, keep iterating. And that's set to true. So in my nested for loop, which is theta of n squared, precondition don't stop has to equal true. And the friendly count is going to be equal to 0. And because there's at least 2 friendly people, the post condition is going to equal false to get out of it. And then the friendly count will be 2. This will be the first 2 friendly people that we find. So as we enter it, P1 is set to 0. And as long as P1 is less than n and don't stop is true, we will iterate. And the second loop here, basically it's going to cycle through. This is setting our P2 equal to P1 plus 1. So whatever our P1 is going into this for loop, it's just going to add 1 to it. And as long as P2 is greater than n, or less than n rather, and don't stop is true, we're going to iterate through this for loop. And this is where we get the n squared, because you have an n for this loop and an n for this loop. So it's n times n. And then this is our black box function. It's our meetup function. So there's going to be 2 people. And if the person 1, in this case, if we're just starting off, P1 is going to equal 0. And P2 is going to equal P1 plus 1, or 1. And if P1 and or P0 rather, P1 equals 0, if person 0 and person 1 are friendly, then it's going to set friendly, it's going to set P1 equal to friendly 1, which is our integer. And so friendly people, we add it to the array, our friendly count, and then we're going to increment. And then we're going to do the same thing with our second person, because we know the only way for this function to go through this if statement is if both are friendly. So we're going to make both P1 and P2 friendly. And then we're going to turn our don't stop to false. So that way, when it exits this if statement, it can no longer iterate because the don't stop is false. And then the second for loop is how we find the rest of our friendly people. So our precondition going in, the friendly count's going to equal 2. And our post condition, the friendly count's going to be at least 2. And the non-friendly could be more, but the minimum amount for this to work is at least 2 friendly people. So for P2, we're going to set it to 0. And then as long as P2 is less than n, we're going to iterate. And then the second part on this for loop, on the second for loop, we're checking to make sure that P2 doesn't equal friendly 1 and that P2 doesn't equal friendly 2, because we don't want to check who we know is friendly versus someone we already know who is friendly. So as long as that is good, we'll iterate this time. We'll go to the next if statement, which is our black box function. And this time in the black box function, we're going to use people friendly 1, which is the person we know is friendly, and we're going to check it against our P2. And then if the person is friendly, we're going to add to our count, our array, and we're going to increment our friendly count. And if the person is not, if it's false, we're going to we're going to add to the non-friendly array, and then we're going to increment our non-friendly. So this will run through the rest of the group of people, seeing who is friendly and who is not friendly. So let's go back to our examples. We have Tom, Penny, Jess, and Bob. So say Tom is going to be our P1, we'll set him to 0, and Penny will be our P2, and she'll be 1. So if they are if we'll put them in the meet function right here, and we'll say that it doesn't work. One of them is not friendly. We're going to go back to this for loop. We're going to increment our P2, and then we're going to make sure that P2 is less than n again, and don't stop is still equal to true, which they would be. We're going to check versus the third person, which is Jess. Let's see if she is friendly or not. So we check it and say she's not, it doesn't work again. Okay, well, either one of the two aren't friendly or both aren't friendly. So we do it again. We'll increment our P2, and then we'll go back, and then we'll check Tom and Bob. So now we're checking Tom and Bob. We'll say it doesn't work. Okay, so we're going to go back up. At this point, our P2 is equal to our n, because we have 4 people. So, and Tom is the 4th person. So we're going to go back to our initial for loop, and then it's going to increment P1. So when it goes to this for loop, P2 is going to equal P1, which is 1, plus 1. So we're going to check again, and we'll say, okay, not friendly. So we go back, and then we increment P2 again. So now we're going to check, the last one was Penny and Jess. Now we're going to check Penny and Bob. Okay. Say that Penny and Bob are friendly. Well, we're going to set P1. We're going to set our friendly one equal to the P1 at this point, which would be Penny. And then our P2 friendly would be Bob. And then we're going to increment both of our counts. So we know at this point who's friendly, well, we know who's friendly. Then we're going to go over here, and we're just going to set all the in this case there's only four, so it's a little bit easier to run through. If you have a bigger list, it would take more time, but I don't have that much time. So we're going to go to this second loop, and then we're going to set P2 equal to 0. And as long as P2 doesn't equal either Penny or Bob, because we know both of those are our two friendly people, we're going to use the meetup function. So say we're going to take Tom, or no, we're going to take people, friendly one, which is Penny, because we know she's friendly, and we're going to test it against P2. So P2 right now is 0. We check it against 0. We already know from here that P2 wasn't friendly. So the 0 person Tom is not friendly. Then we keep checking. We'll check. Penny can't check herself because of this, so we iterate again, and then Penny checks Jess. Okay, so each time when she checked Tom and Jess, they both got added to the not friendly people, and it incremented our non-friendly counter. Okay, so Tom not friendly, Penny's friendly, Jess is not friendly, and Bob is friendly. Now, the last part of the problem is we have to sort them. So for my sorting loop, our precondition is that we've got, all of our friendly and non-friendly targets. And our post condition after this is done is that they're going to be sorted. So we go to the for loop. We set I to 0. And then as long as I is less than friendly count, we iterate. Non-friendly people, we take the array, we equal it. Since the last for loop had it already decremented, non-friendly has a space. And we're going to put the first friendly person and append it to the end of the non-friendly array. And then we're going to increment I. And we'll do that as many times as we have friendly count. So however many friendly people we'll have, this is how many times we're going to append to the non-friendly array. So when we're all done, we're going to return our non-friendly array, which will have all of our non-friendly people. And then at the other side appended will be all of our friendly people. And that is the code. The nested for loop is n squared, and then my next loop is n, and then n. It's only n. N squared is the highest, so it's going to simplify to n squared, because you always want to use the fastest growing asymptotic bound, because if you look at this, once you, even at 2 people, it's already far ahead of n squared is already far ahead of n. And then at 3, it's even further, and it only goes up. And I use this count to show you what the numerical value would be. Conclusion. I learned a lot doing this project. And I know that, knowing the time complexity of coding and what your asymptotic bounds are for your highest portion of your algorithm, what that can do to your compute time. And, we've got computers, quantum computers now that are just now solving some of the algorithms that we weren't able to solve before. And it's because their complexity, their time complexity was extremely high. It was huge, and we didn't have the power to do it. But anyways, the faster that you can solve problems with coding, and the quicker you get things done, and the easiest way with the least amount of problems is always the best way. But I hope you enjoyed this, and I hope you learned something. See you next time.